mentally checked out.
Are you? Well, that's not good.
I want to weekend mode. All right.
I'm not. I don't know. There's things we got to do here. All right, so realistically, we're going to talk about what is called translation and rotation of axes a little bit. We're gonna spend some time. Basically, section 4 is going to be all about, like I said, a little bit of translating these around. We'll talk about the translations and rotations a little bit. We're not going to get too in depth because you're able to graph things. Some of these concepts are much easier now that you can graph things very easily on Desmos. The graphing calculator was much more complicated because you had to solve for y, and you had to do a bunch of algebra to get there. So this is going to be a little bit easier than it used to be. Okay, so we're going to talk about classifying or identifying what type of a conic we have. We'll do a little graphing, that'll be easy on Desmos, and then we'll do a little completing the square also. Students will be able to determine equations equations for and graph rotated and translated conics. We've kind of already dealt with translated conics. We've moved them around a little bit. This will just be a little bit different. Now, if we have, now looking at what we have here, if we have a rotation, and let me get my pen working here. A second here. All right. If we have an equation for a conic that has been rotated, we're going to see a term like this. All right. If we didn't have that term there, that's realistically just like the conics we've dealt with before. All right. Ax squared plus cy squared plus dx plus ey plus f. We could figure out what that is without a lot of trouble. Okay. Now this term right here, like I said, is what's going to cause things to be rotated. Okay. That xy term, that's what's different. That's what's new here today. All right. So this is a little bit of a test here. If we get a second degree equation of a conic in this form, ax squared plus bxy plus cy squared plus dx plus e plus f, we get it in that form, we can use what's called the discriminant test to determine what type of a conic section. You could also graph it to determine that, but you can use the discriminant test to determine that. Okay. So for example, here is, and this is going to look pretty like a maybe simplified form here. Here is an equation of a conic section. There's no x squared, there's no y squared. I realize that, but trust me, that is a conic section. I think it's going to be hyperbola. Now, realistically, if we wanted to use our discriminant test to determine what type of conic section is, and once again, you could graph it too. I think there's no x squared term, so a would be 0, right? B would be what? -4. That's our xy term. And since there's no y squared term, that would be 0, wouldn't it? So I'm kind of identifying what these values are for this discriminant. The discriminant is just like we talked about back with the quadratic formula, was the part under the radical. Isn't that b squared minus 4ac? Okay, so that's really the same idea. So if we found b squared minus 4ac in this case.
Mr. Murray?
Yes.
Can Maddie Clabo come to the office for a minute?
Yes.
Thanks.
So b squared minus 4ac, we'd have -4 squared minus 4 times 0 times 0. Well, that's 16. And since 16 is bigger than 0, it's a hyperbola. Does that make sense? All right, so this little test will determine, if you're not aware what the conic section is by looking at the rule, you can use this discriminant test to help you. Okay. Now, like I said, you can also graph things, and you might be able to determine it's a hyperbola that way. So why don't you graph this one, and you can probably see it's a hyperbola. All right, graph that equation on Desmos, please. And then you can see that it's actually a hyperbola. You need to graph that. Yeah. You can't be checked out till 10:20. It's Friday, it's not Thursday.
You can't be thirsty on Fridays?
Oh, you said Thursday.
I said I was Thursday.
You said it's Thursday.
When?
I'm kidding. Gosh.
Talking.
Thursday, get it?
Oh.
Uh-huh. Gonna keep your attention here. Is it a hyperbola? Yeah. Gotta make sure. Doing it wrong. Okay. No, it's a hyperbola, right? And is it a hyperbola that's a little different than what we're used to? We've talked about them that were vertical and horizontal. This one's kittywampus. Isn't that, you've heard of that term, have you? It's rotated, right? Okay, it's been rotated a little. All right, it's been rotated a little. It should look like, I think this is what it looked like, didn't it?
Oh, yeah.
Yeah, it should look something like that. That's a hyperbola. So once again, that's not vertical, it's not horizontal, it's kittywampus, right? There you go. New word for today. It's a vocabulary word. Kittywampus. All right, now, what if I gave you another equation? Well, let's see here. And I'm gonna get rid of some stuff here. I'm gonna clear this stuff out. What if I said, can you figure out what this one is? And I'm being nice because this is in the form that you need. What type of a conic would that be? Well, once again, some of you are going to jump and graph it right away. I know that. But we could also classify it by using the discriminant. Right? Classify it using the discriminant and then, you know, see where it ends up. The discriminant's either going to be positive, 0, or negative. All right, so let's find the discriminant here. B squared minus 4 times A times C. What's that? That's 16 minus 64, right? Which is negative 48. And negative 48 is less than 0. So that one has to be an ellipse, right? That make sense? So if we have a conic section with that, you know, term that causes the rotation, it might not be obvious that it's an ellipse or a hyperbola or a parabola. This discriminant test will tell you. Okay, why don't you graph that one too, please? I'll give you a little time to do that. We can always check the discriminant test with our graph too, right? But this should be an ellipse, and I think it's going to be rotated one way. You already got it?
I did.
Did you? Okay.
It's a crooked circle.
What? It's not. It's an ellipse.
Oh,
It's an ellipse. It should be an ellipse that's tilted, right? Or rotated. All right. So now we're opening it up, and this might be helpful when you start looking at, you know, making your projects. If you wanted to move things around a little bit, that XY term, if you wanted to rotate something, you'd need something of that sort. Okay. All right. How many people have graphed it? Have all of you graphed it? Do me a favor. Change that to plus 4xy. See what it does. Let's just change the rotation. It just changes the rotation, right? So it's still an ellipse. It just changes it a little bit. It kind of goes from the upper right to the lower right. Okay. Just that's how you can play around with that extra term there to change the rotation. Do another thing. Let's make it 8 instead of 4. What does that do?
plus 8.
No. Excuse me. Don't make it 8. Because if I make it 8, it's going to turn it into a parabola. I bet. Make it 8 once.
Yeah. Or I don't know.
It turned it into a parabola. Yes, it did. The negative 4 turned that to 8. That turns it into a parabola, doesn't it? Because now would our discriminant be 64 minus 64, which would be 0? Which would make it a parabola, right? Okay. Okay. So make it 7 once. That'll still be an ellipse.
Negative 7 or positive?
Doesn't matter. Did it change it a little bit? Yeah. Did it make it wider or like longer? Stretch it out. Okay. So you can mess with that term and you can make things, you know, look a little bit.
What does the except for degenerate cases mean?
I wouldn't worry about that. Okay. I can't give you a good answer on that right now. because I don't know, honestly.
Well, then it's probably not gonna be
Yeah,
that.
no, I wouldn't worry about it. I honestly wouldn't worry about it. Could be those kids that give us a lot of trouble, degenerates. I'm kidding. None of you are in here. None of those kids are in here. Well, maybe. Come on now. Keep your attention here. So this is some examples of some different figures. Okay. Side of the discriminant gives you the values of A, B, C, and D. These are some really simple equations, all right, compared to what we saw, all right, that last one, all right. All right. Now, I want to move ahead to this. Now, if we're looking at what's called a translation formula, okay, basically we're taking and we've done this, we're taking a conic that is centered at the origin and we're moving it around. We're moving the center, right? Now, if you look at this one right here, it doesn't have that XY term, so there's no rotation, okay? There's no rotation. Now, we could still use the discriminant to determine what type of a figure it is if we really wanted to, okay? So let's do that real quick here. B squared, what's B? If there's no XY term, what's B? 0. So we'd have 0 squared minus 4 times 9 times 4. Well, that's obviously going to be less than 0, isn't it? So this is an ellipse, okay? This is an ellipse, okay? Now, could we come up with the standard equation for that ellipse? All right, we definitely could, which means we need to find the center, and we basically want to make it look like, you know, if it's an ellipse, we have to make it look like this. But you know, we have to make it in terms of the new center. So I probably should have said x minus h squared and y minus k squared. Okay. Okay. So I'm going to erase that. Okay. And the other thing is I don't know necessarily which way this ellipse is orientated. It could be tall, it could be wide. I don't know by looking at the rule right now. I just know it's an ellipse. Now, how do you think we can turn that into standard form? That's where completing this work comes in. Now, we did a little bit of that in that review, and we reviewed that earlier with that one question on the quiz, first question, right? So we're going to go through the process of how you would complete the square to turn this into a standard form equation. Okay. Well, here we go. Oops, I got to get to my pen here. I'm going to get my x's together, and I'm going to get my y's together, and I'm going to throw the 11 over to the other side. Didn't do anything crazy there, just moved things over, okay? Move things around, I rearrange things. Now, we're gonna have to complete the square here, and we're gonna have to complete the square here, right? We're gonna have to do it twice because there's basically two quadratics there, all right? Now, when we reviewed completing the square, what was it, Tuesday? Didn't we say, I don't wanna complete the square with this being 9? So what do I have to do? Factor it out, all right? So here we go. 9 times x squared plus 2x plus blank. All right, I'm going to stop there and we'll say that one's good. We're ready to complete the square now. Same idea. Am I going to be able to complete the square here if that's a 4? No, I really can't. I don't want to because it makes it more complicated. So we're going to do the same thing. We're going to factor that out here. Now, if you look on the right-hand side, I put 2 blanks there. Hopefully you understand why there's 2 blanks there. I'm going to have to, in order to complete the square for both of those, I'm going to have to put something here and here, something different in each case, right? And then whatever I add to the one side, I better balance it out by adding it to the other side. So what would go in this blank right here? What would make that a perfect square trinomial in those parentheses? 1. And how do we get 1? Divide 2, it's b divided by 2 and then square it. Where our b value is 2, so it's 2 divided by 2 is 1, 1 squared is 1. So really I've added 9 over there, didn't I? 9 times that 1. Okay. So balancing my equation, I got to be careful here. Now, what are we going to use as our number here to make this a perfect square?
4.
Half of -4 is -2. -2 squared is 4. So that means I better add 16 here. Right. Questions on that? So far, so good? Well, now this becomes 9 times x plus 1 squared plus 4 times y minus 2 squared equals 36. Now, is that looking a whole lot more like standard form equation that we worked on before in the first part of chapter 8? I think so. We're really close to having it in standard form. What do we have to do? What do we have to do to get that in standard form? We know it's an ellipse. Equal to 1. So divide everything by 36, right? We had to do a step of algebra. So I'm gonna rearrange things a little bit too as I do this, just so you know. I'm gonna say it's y minus 2 squared over 9 plus x plus 1 squared over 4 equals 1. Now, does that look like standard form we talked about in section 2? All right. So now we know that we knew it was an ellipse, and we found the standard form equation for that ellipse. All right. We're not going to worry about, we're not going to worry about the translations too terribly much. Now, the reason I wrote it with y squared first is because isn't this going to be a tall one? Taller than its wide. What tells us that it's taller than its wide? This is bigger. This is bigger, right? Yep, that's what you're saying. Sorry, I shouldn't have. That number's bigger. All right. Now, in the text, you may see this written like so. You may see it written this way. And this is what they would call transformation form. We're not going to get too in depth into that. I'm just going to show you that. And they would say that y prime is y minus 2 and x prime is x plus 1. Okay. I don't think we need to worry about this too much, but when you see that y prime notation, that's what it's getting at. Okay. They're basically saying what's in green and what's in red at the bottom, not right at the bottom there. What's in green and what I'm circling right here, they are really equivalent. Would you agree? Through substitution. And that prime basically just, it's the transformation. I'm more concerned, and like I said, we're not gonna worry about the term degenerative cases. I'm more concerned on how you get it to look like this. Okay. The algebra that you have to do to make it, to get it in the standard form equation. What's circled in red there is just rewriting it in what's called transformation form. Okay. So I'm more concerned about the algebra that'll get you there. And once again, that's completing the square. That's completing the square. Okay. Questions on that? And I'm going to get rid of all my work. You're going to see on the next slide, that's all the work they did. We did all the same work together, right? It's the same thing. Right? And they didn't switch it around, but you see this, the standard equation of an ellipse, if we let x prime equal x plus 1 and y prime equal y minus 2, then the equation becomes, that's what we had in red, right? That piece down there. Okay. And that's kind of piggybacking off of this. Okay. We're not going to get too terribly far in depth with that. Okay. We're not going to worry about that too much. but I want you to know what it looks like and what it means, okay? All right, I think maybe should have you try one without me. We'll come back together after all said and done. So we have, this is a conic section. All right, first of all, looking at it, what do you think it is? What type of conic section do you think it looks like? Okay, I'm going to disagree, but that's fine. Why would, can somebody, I mean, it's not in the list, okay? No big deal.
I think it's a hyperbola.
Why?
Because B is 0.
B was 0 in the last one and it was an ellipse. So no, I wouldn't go that far. It is a hyperbola. All right. Now, to reinforce it's a hyperbola, B squared minus 4 times A times C, is that bigger than 0? That's a positive number, isn't it? Now, this is what kind of told me it's a hyperbola. X squared minus Y squared, rather than X squared plus Y squared. See what I was looking at? Okay. But it's always good to check the discriminant, right? It's always good to check the discriminant, right? But I see that X squared minus Y squared, that kind of tells me it's a hyperbola because of the definition. All right. So here's what I'd like you to do. Convert this to a standard equation, which means complete the square and rewrite it in standard form. I'm going to give you at least till after 10 to do that, about 5 minutes or so. Should be very similar to what we just did. This one might be a little bit easier. Be careful with signs, okay? Be careful with signs. That's one word of caution. And when you're done, if you wanted to make sure you're right, you could graph the original problem and graph your standard form equation, and they should be the same, right? They should be the same. Yes, I'll let shoes on. I'll let you today. I think it was wide. I think you're right. And it's on the PowerPoint too, if you want to get that. But I believe that's it. All right, so if you wanted, when you're done to check it, you graph this and the standard form equation you got, and they're the same hyperbola, you're on the right track. If they're not, then there's a mistake somewhere. Right? Decimals can help us check things. Again, when you're done, graph yours and the original and see if they're the same. If they're not, there's an issue.
Oh, yeah.
This one's maybe a little tricky. Or yeah.
No, this is-
Yes. Right. It's in. You know what it's going to be negative, right? So really, you put a 9 here.
So should I write this one here?
That's a 16. This one's a little trickier. It is. Oh, definitely. I'm going to start doing a little bit of the work there. And I'll stop when I get to a point where there's something important. All right, now, Mike, anybody get it right? This is a tough one. Did you graph what you had in this? That's what I can try. Now, what makes this one tricky is this right here. Okay. That's what makes this one tricky. All right, and I kind of gave you a word of caution to be careful with signs. Just like I don't want to complete the square here if this is 16, so I'm going to factor out that 16. I really don't want to factor this with this being a -1 out front. I want it to be a positive one. So I'm going to factor out a -1. Does that make sense? That's probably, if you made a mistake, that's probably where it happened. And that's why I said be careful with signs. You understand? It's a little reminder. Okay, a little reminder. Now we're ready to complete the square, correct? What goes here? So then what did I add to that side? 16. Okay. Now, what goes here?
9.
So what did I do to this side? -9. Yes. Anything in those parentheses is really the opposite of what it appears, right? So this was 16. This is -9. Okay. Questions on that? This definitely makes it trickier. I agree. But then I believe the hard part is over. That was the tough part. That was a tough step. Because after that, this becomes 16 times x minus 1 squared. Subtract y plus 3 squared equals 64. Is that a nice number? Yeah, because that's going to go into things. That's a perfect square, so that's going to work out pretty nice. Even if it wasn't, it's going to be pretty nice. Questions? All right, so realistically, this step right here, all of this work here was the part where you have to be very careful. All right, because now we just have x minus 1 squared over 4 minus y plus 3 squared over 64 equals 1. All right, so what I circled there, that's where you have to be careful, right? That's where you have to be careful. All right. So if you were to graph what I have down here at the bottom in red and what we begin with in black, they should be the same. Right, perfect. Too much for Friday? Well, I don't think so, but that's what we're doing today. So now we can come back to this on Monday if we have questions. But I think that's about all I'm gonna.
Can you go over how you got to the last red equation?
From here,
How did
how did I get to red?
From the square to the blue first. I don't know that either.
This is how I got from the blue to the red, divided everything by 64.
Okay.
And then that becomes 1, right? How did we get here? Well, this is going to be the perfect square of x minus 1. X, and when we cut -2.5, we got -1, right? So that's why it's x minus 1. That sound familiar from last year? Here, This was y, and then when we cut 6 in half, we got positive 3. So that's why it's y plus 3. Okay. And then the last step was just dividing that by 64. All right, any other questions? All right, that's it. I'll let your brains take a little break here. 3 through 30, multiples of 3. Now, we're really not going to get back to the textbook. We can go over questions on Monday, but we're really not going to get back to the textbook on Friday. Because Monday, I'm going to introduce that project. We can go over, we can review this on Monday if you'd like. So, entirely up to you guys. Tuesday's the ACT. Wednesday, Thursday is working on your project. I'll let you do that in your class on your iPad. And then Friday, your project is due. And we'll get back into, we'll start section 5.
Are you doing a video Monday, like when you're explaining?
I wasn't planning on it.
Can you so I can listen to it?
We'll vote on it.
Can I go to the bathroom?
Yes.